Hey everyone! So today we're going to go back into our tutorial questions. We haven't done that in quite a while. So today we're going to do the application of integration, mainly about finding the volume. So this question right here in front of you appears in your textbook. I believe it was question 19, and I thought it was actually quite intriguing. So let's have a look into that. So the shade region is rotated around the x-axis to form a volume of revolution. Find the volume of this solid. So as you all know, hopefully by this point in time, that the volume formula is equals to pi, and then your integrand. In this case, because we have two graphs, it's usually the one on top. So let's just call that fx. The one on top, you square that, minus the one at the bottom, you square that, dx. Or if it's just one graph, if you want to just find the volume of one graph from the x-axis, of course, rotate around the x-axis, then it's just f x squared, and that's it. And then from b to a, and same over here, b to a. So that's just general notes. We'll just leave it there. We might need it soon. Okay, find the volume. So in this case, we have a circle, and we also have y squared equals to 3x, which is pretty much a square root graph. And we want to find this shaded volume right here, shaded area, and then get the volume after it's rotated around your x-axis. So yeah, this shape, if you can imagine, it'll just look like this, and then you got volume going on, 3-dimension, yeah, something like that, you know, close enough. But how do you do that? Most students would go in most students would think about, wait, there's two graphs, so I have to use the first formula, the one where if it's rotated around the x-axis, there's the top minus the bottom. The problem here is which one's the top, which one's the bottom, we don't know, right? Like there's no argument. Like the red side over here, it's to left, and then the blue side's right, and then yeah, so there's actually no top or bottom. The trick to doing this is actually finding the intercept between these two graphs, and then, so we don't know that where that is, and then we get the volume of this area number one, and then we get to add it to the volume of this second area. Therefore, if you add them together, you get the entire volume. So that's the handy trick you might come across in the exam, even in the SAC. It's really important. So let's get into this. How do you find the area of the first volume? So we're going to do volume number one. That's pretty simple. Just use your first formula right here. Pi, b to a, we know a is 0. And what is b? B is this intersection point. How do you get the intersection point? Just equate the graph together. And in this case, we know x squared plus y squared equals to 4. What do we know about y squared in this graph? Well, y squared equals to 3x. So we just sub that in. So all we did is just sub that over here. Right there. Okay. And then you solve for it. X squared plus 3x minus 4 equals to 0. X plus 4, x minus 1 equals to 0. Therefore, you have two answers, x equals negative 4, x equals to 1. Now, which one do you pick? Very obvious. This is on the positive side. You pick 1. So your intercept is 1. You put 1 to 0, and then we use our formula, fx squared. I've got a dx. Just write in your fx squared. So this graph, the red graph, that's 3x. So put it right here. 3x. It's already square, y squared, so you don't have to square it again. And then yeah, just integrate that. You get volume number 1. And then you add it with volume number 2. So volume number 2, you just add that with volume number 2. That is pi. So you always have a pi in front because it's volume of solid of revolution. So you should always have pi. And it's 2 to 1. And it's on the circle instead. It's not the red, not your square root graph, it's the circle graph. And in this case, our circle graph, if you just manipulate your equation right here, y squared equals to 4 minus x squared. You already have your y squared, so all you have to do, chuck in 4 minus x squared right there, dx. And then after this, it's just easy solving. You got volume number 1 plus volume number 2. Split your graph so that you have these two volumes and the intersection split by the intersection at 1. Then you can solve this. I'll do it quickly here to get your answer. So pi 3 on 2 x squared 1 0, and volume number 2, it's pi 4x minus 1 over 3 x cubed 2 to 1. And of course this should, and of course this should give us 3 over 2, sub in 1, sub in 0, doesn't matter. And this one should give us 8 minus 9 on 3, 8 on 3, my bad, not 9 on 3. And then we minus sub in 1, that's 4, sub in 1, that's negative 1 on 3. And we're almost there, that's 3 again, pi on 2, plus pi. And let's do some maths. Oof, 8 minus 8 on 3 minus 4 plus 1 on 3. That should give us 4 minus, so let's just do it on the side. 4 minus 8 on 3 plus 1 on 3, which is negative 7 on 3. And then we just have it as 3, that's 12, so that's 5 on 3. So final answer, just add these two together. Make them have the same common denominator, 6, so that's 9 pi, plus this one times it by 2, 2 times 5, 10 pi. Final answer, 19 pi on 6. Make sure you just add that units cube right there, or cubic units, whichever one you prefer, and that's it. Final answer, 19 pi on 6. And that's it for today, guys. Tutorial questions. So, circle, it's not always the top minus the bottom, right minus the left. In this case, it's just using them individually. It's all about just getting your graph, seeing it, trying to be creative. But aside from that, all good. And I'll see you next week, guys. Thanks for watching.